Good morning, friends. It gives me immense pleasure to be here again for my course, Engineering Thermodynamics. As of now, we have covered so many topics on thermodynamics, concept of basic thermodynamics, properties of substances, work, energy, first law of thermodynamics, zeroth law of thermodynamics, phase change, temperature and pressure relations, and the properties of the substances. Today we are going to handle some problems related to the heat flow direction and the work done. So today's class we are going to discuss about numerical 1, the first numerical, finding work done due to aerodynamic forces of a raindrop. In this we will see that if one drop is falling from sky, the shape is as a spherical shape, but when the wind is coming, the spherical shape is converted to the cylindrical shape. So by the conversion of this shape of a drop of raindrop, how the work is affected. This is going to be handled by the numerical number 1. So in this, we will find out the work done when the aerodynamic effect on the drop is experienced. The second problem is finding heat transfer of piston cylinder arrangement. So in this, normally we take a typical example of piston and the cylinder, and in this cylinder, we give some heat by the help of some petrol or diesel or some any other fuel which we burn inside, that will give the heat, and by this action how much heat is transferred and how much work is done, this will be handled and this will be explained in the numerical number 2. If you talk about numerical number 3, it is the finding the direction of the flow energy. So how the direction of flow energy we can obtain by the help of entropy relations. So in this we will be handling the direction of the flow. So the first problem I am going to take is a spherical water droplet of diameter 1 millimeter is subjected to a constant aerodynamic force for a short time interval, during which the droplet deforms into a shape which looks like a disc of diameter 2 millimeter. The droplet just changes the shape but does not move. So it is only changing the shape. We are considering that by the aerodynamic forces, it is a spherical shape, and if you give the wind, this is from spherical, it is become a cylindrical with a diameter of 2 millimeter. Previously it was a sphere of 1 millimeter. The droplet just changes the shape but does not move. Means there is no motion of due to the aerodynamic forces, only it is changing the shape of the drops. Once the force is cut off, the droplet regains the spherical shape. So once you remove this aerodynamic force, so it is from cylindrical to again spherical, it is becoming. Calculate the work done by the aerodynamic force and neglect the viscous forces. So here we are not considering any viscous effect of this. So we can see that. Just I will explain first what is the problem, then we will be discussing about this. So first, initially the drop is in spherical shape. In all the direction it is diameter of 1 millimeter. This is the phi of 1 millimeter and it is a sphere. Now the wind is aerodynamic forces, means the wind is moving from this direction. This will generate the aerodynamic forces. These aerodynamic forces will try to change the shape of this from a sphere to a disc. So if I make it like this. So now this is now phi of 2 millimeter, that is phi is equal to 2 millimeter, and this is now h. So this we have to find out how much work is done by the aerodynamic forces. This is the problem. Before we start the problem, I think you have understood that what we want to do. We want to know that how much work is done by the aerodynamic forces from converting from sphere to a disk and from disk to again a sphere shape. So here I have mentioned the same diagram here. This is the sphere here. This is the sphere. This sphere has diameter of 1 millimeter. Now here we have some aerodynamic forces. Aerodynamic force, and this shape is converted now to phi is equal to 2 millimeter diameter, and here this phi is equal to 1 millimeter diameter. It is looking like a cylinder. So it is a disk. Okay. So this we have to solve, and we have to see that how we can go ahead. So it is drop is in spherical shape of 1 millimeter as shown in this diagram. Figure number 1, just I am writing here. Figure number 1, and this is the figure number 2, which converts to 2 millimeter dia of disk like the cylinder. It is shown here. We know the volume of the sphere is equal to V1, that is pi d cube by 6. So pi into d is equal to 1 millimeter. So 1 into 10 to the power minus 3 cube divided by 6. By solving this, we will get 0.523 into 10 to the power minus 9 meter cube. This is the whole volume of this sphere. Now this sphere, the same amount of liquid which is a part of sphere is now converted to a disk as shown in the figure 2. The volume is same, means V1 is equal to the V2. But how much is the V2? The V2 is the volume of the disk, where the diameter of the disk is 2 millimeter and the thickness of this thing is h. But h is not given. H we have to find out by the help of V1 is equal to V2, because the volume is the same. So now volume of the cylindrical disk V2, we know that pi d squared by 4, this is the area, into this is the thickness or the height of this disk. So now due to the conservation of mass, we know that V1 is equal to V2. So here the V2 is equal to 0.523 into 10 to the power 9 meter cube is equal to pi d square by h, pi by 4 into 0.2 into 10 to the power minus. This is the diameter phi is given 2 millimeter. This 2 millimeter is equal to 0.2 into 10 to the power minus 3 square into h. So h is equal to how much? So this h is equal to, here just I am writing, h is equal to 0.523 into 10 to the power, here it is a 9, okay, sorry, it is a 9, 10 to the power minus 9 divided by into 4 divided by pi into 0.2 into 10 to the power minus 3 square. Okay, so you will get this height or this thing, you will get h is equal to 0.16 into 10 to the power minus 3 meter or 0.6 millimeter. So this thickness here, this you got here, from here to here, you got as a 0.16 millimeter. This you got. Now, the deformation from sphere to the cylindrical drop gives work done due to change of area of the surface. So, initial surface of the sphere. So, what is the surface area of the sphere? Pi into d1 square, that is the A1. So, this is equal to pi, d is equal to 1 into square. This is 1 into 10 to the power minus 3 into square. It is 1 into 10 to the power minus 6. So we can write that it is 3.14 into 10 to the power minus 6 meter square. This is the area. This is the area of the sphere. Now we have to find out the final shape after deformation is a disc with a diameter of d2 and the height h. We have two faces, top and bottom. So here, this you can see, this is the one face, and here is also one face. So this face is equal to pi r square. Pi r square plus pi square I square. So here 2 into pi r 2 square plus pi d2h. This is the height. So this surface area of this here, this is pi into d2 into h. So we can write down here that 2 pi here plus 2 pi into 0.16 into 10 to the power minus 6 we have taken common. We can also take the 2 pi also. So here 1 plus 0.16. Okay, so here we will get 6.38 into 10 to the power minus 6 meter square. So this is the area of the disc. So what is the difference between the area? So this delta A is equal to A2 minus A1. So A2 is equal to how much and A1 is equal to how much? A2 we got 6.38 into 10 to the power minus 6, and if you see the A1 is equal to 3.14 into 10 to the power minus 6. So this you can see here that A2 is equal to 6.38 minus 3.14 into 10 to the power minus 6. So you will get here 4.14 10 to the power minus 6 meter square. This we have got the area. We also know that this sigma of the water, that is the surface tension of the water, is 0.072 Newton per meter. Okay, so this we should remember. Okay, so here work is done due to the surface tension and change in area of the system. So here of the bubble, so work due to the surface tension is equal to minus sigma delta A. So action and the reaction, so opposite force. So work done by the aerodynamic forces, that is sigma delta A, and this sigma is 0.072 Newton per meter square. So 0.072 Newton per meter square into change in area. Change in area is how much? 4.14 into 10 to the power minus 6 meter square. So you will get here, if you multiply 0.072 into 4.14, you will get 0.298 into 10 to the power 6 Newton meter. Okay, so here we can write this is as a microjoule. So Newton meter is a joule. So here we can write 0.298 microjoule. So this is the answer. So this much work is done by the aerodynamic forces, and this will be, if you talk about the surface tension, then it is a minus 0.298 microjoule. So by the aerodynamic force this much it is positive, and by the surface tension it is the negative. So that is the difference between two type of work done. So work done by the aerodynamic is positive because it is taking it out, but this surface tension is work is going inside. So that is the negative, which we have already taken the this conventional way in our previous lectures, that if the system is like this, so work out is positive and work in is negative. So here this shows that this one shows that this is the work in, means it is entering inside this work is entering inside the bubble, and this one, the aerodynamic forces, it is going out of the bubble. That is the indication. The sign we have to take very much care, then only we will be able to solve the problem, and we should also try to understand the problems. Hope it is very much clear, and So in this we have tried to solve the problem for a natural raindrop. These raindrops, when it is falling from the rain, as a rain, there will be some wind. This wind will change the shape. You might have seen that they are all are not as a sphere shape. As and when they are moving, their shape is changed due to its wind direction. So in this we have just discussed about that. Now the second problem we are going to discuss about frictionless piston cylinder assembly, which is most typical problem which we normally take in our thermodynamic courses, because this is mimic the piston and cylinder, mimic the basic thought of aerodynamic processes. So just I will go with the problem, and this problem is taken from the reference 1, that is the one problem. Okay, so a frictionless vertical piston cylinder assembly fitted with an electrical resistor contain air. The mass of the face area of the pistons are 50 kg and the area is 0.1 meter square. The atmospheric pressure is 100 kilopascal. Electric current is passed through the resistor, causing an increase of 0.05 meter cube in the volume of the air. Means the delta V is 0.05 meter cube of air. The mass of the air is 0.4 kilograms. Because of the heating, its specific energy increases by 43.3. So its specific energy is delta U. So delta U is 43.3 kilojoule per kg. Assume the assembly including the piston is insulated, means there is no heat flow. That is means del Q is equal to 0. This is the condition which is given. Determine the heat transfer from the resistor to the system. For a system consisting of A, the air alone, the B, the air and the piston. So here two things are there. That one, if you take the, this is your cylinder, this is your piston, here is the air. Case 1 is only air. If you see here, this is air. I am just putting a dot line here. This is the line. This is the system for the case 1. And if you take the another system, so in this we will see including the piston. Including this piston also comes under system. So this, it is asking two cases. The case 1 when air is only the system, and the case 2 air plus piston is the system. So what is the difference that we have to find out by this given problem. We hope this del Q is equal to 0 means there is no heat transfer. It is not going inside and it is not going outside. So we can very well use the first law of thermodynamics in that this del Q is equal to U plus del W. So here U is also given and delta Q is equal to 0. So we can find out, and delta U is also given. So it is very simple to find out the your work done and the heat transfer from the resistor. So here we can see here that this is the sketch which, and I have shown that this is the cylinder and the cylinder is this hatch. This hatch indicates that it is a Q is equal to 0. This hatch indicates that heat transfer is 0. This is the electrical source and this is the coil and this is heating the system. Inside, we can see that this is the system. When we take only air as a system, we are not taking this coil also as a system. Neither we are taking this piston as a system. So, and this is insulated. So, Q is equal to 0. So, these things are given. And also it is given that mass of the piston is equal to MP is equal to 50 kg. So, if you see here, this is the 50 kg. 50 kg, this is the mass is given. Area of the piston, this is the whole area of the piston is AP is equal to 0.1 meter square. Change of volume is 0.05 meter cube. So initially it is a V1. Now after that it is a V2. So next your piston is here. So this V2 minus V1 is equal to delta V, and delta V is given 0.05 meter cube. This is given. Mass of the air inside is 0.4. Mass of air is given 0.4 kilojoule. Specific energy, change in specific energy, small u is equal to 43.3 kilojoule per kg. G is equal to 9.881 meter per second square. So, system is isolated. So, we have to find the heat transfer when a system consists of only air and the system consists of air and the piston. So, these are the two cases which we are going to discuss in this problem. So, we have to see first the free body diagram, FBD, we have to make, and this is the piston here. This is the piston. Here, upside, from top, the atmospheric air, P atmospheric will act. From the bottom, the air pressure will be acting, and the mass of this thing will also act downwards. So, total force P air is equal to P atmosphere plus pressure of this piston. So, here we should know what process it follows. The weight of the piston assembly to move downwards. It is trying to downwards. So, MP into G, total weight of this piston plus total force on the upper side, that is P atmosphere into area, is equal to P air from the bottom into area. So now if you divide by area, this has gone, and here it has come A. So MPG by A plus P atmosphere is equal to P air. MP is given 500 plus 9.81 and area is 0.1. This is given 100 kilopascal is equal to P air. So this P air is equal to 104.9 kilopascal. So this we are getting 104.9 kilopascal. So this we have got it here. So here it is a 50. Okay. 50 kg. So now we have to use the first law of thermodynamics, and we know that the internal energy is equal to del Q minus del W. So delta E is equal to Q minus W. This, if the kinetic energy and potential energy are change in KE and PE are negligible, then this can be converted to specific energy. So this specific energy delta U is equal to Q minus W, and we know that this is the capital. So if you make the small u, this will be multiplied by air. So M of air into delta U small is equal to Q is 0.4 into 43.3. So this is given here. 43.3 specific energy is 43.3 and air is 0. The mass of air is this thing, and W is equal to 0. Okay, so this Q is equal to 0. It is insulated. No change in heat. So we got here that M into delta U air is equal to 0.4 into 43.3. Now the work done is equal to 1 to 2 PdV. So here P of air, which we have obtained this one, P of air and into change in volume from 1 to 2. So P of air V2 2 minus V1, P of air delta V is given 0.05 meter cube, and P air we got 104.9. So 104.9 into 0.05, you will get 5.24 kilojoule. This is the work done by the system. Now we can see that how much heat is changed. So now Q is equal to delta E plus W. So delta E we have, how much we got? We got 17.32, and W we got 5.24. So net heat is equal to 7.32 plus kilojoule plus 5.24 is equal to 22.56 kilojoule. So this much heat is likely to transfer if not insulated. Okay, so this is the first case. Now, when air is only the system, we are taking when air is only the system. Now we will take the next. In this next case, solution of B, when piston and air both are the system. So now you can see here that this line here, your system is now, piston is also covered as a system. This I am drawing here, this black dots. So heat will remain the same because it is insulated. As the system is insulated, so transfer of heat from, in this case also it will be 22.56 kilojoule. There will not be any difference whatever because it is an insulated system. Here the piston is now part of the system with air. Only atmospheric pressure will be used for the work. So here, if we calculate the net free body diagram, so in this free body diagram, if you see, only P air, P atmosphere is only, and this is equal to the P air. So P air is equal to P atmosphere is equal to 100 kilopascal. So here the weight is not considered because it is part of the system. So work done in this case is equal to P atmosphere into delta V, and delta E is equal to 43.3 kilojoule per kg. It is given. So this work done is equal to 100 into 0.05, 5 kilojoule. So so we got the 5 kilojoule. Now internal energy delta E is equal to M into U, 43.3 into 0.4 plus 5 into 9.81 into H. So if you know this H means how much it is traveled, this is H. So H we can find out is equal to delta V by area of the piston. So this is 0.05 divided by 0.1. So 0.5 meter it has traveled. This distance, new position from here to here, initial, it is 0.5 meter. This is the H. Now if you see the potential energy is equal to mgh. So 50 m 9.81 in 0.5, you get 245 joule or 0.245 kilojoule. So this delta E is equal to 43.3. Here it is 0.54 plus 0.245. So you will get here 17.32 plus 0.25. But we know that the heat transfer Q is equal to dE plus dW. So dE is equal to how much? 17.32 plus 0.25 plus this is the 5 here, plus 5. So you will get 22.5 kilojoule, and here also 22.56 kilojoule. So Q of can be of the same. So in this case also and in that case also, we have proved that there is no heat transfer. It can be converted from potential energy to kinetic energy, kinetic energy to potential energy, but in the system the heat will remain the same. So that is the second problem which we have tried to solve in this case. So hope this two problem. First one was related to the drop. This one effect of aerodynamic forces on the rainwater, which is converted from spherical shape to the cylindrical shape. And the second case was here. In this, there was a piston which is the frictionless, and how much heat is generated and how much heat is transferred from the register to the system for a system consisting of the air as the system alone and the air and the piston as a. In both cases, we are getting the same answer because it is insulated, and we will get the same amount of heat because it is not going out. Now we will see another problem. In this problem, we should find out the direction of the flow, in which direction the heat will flow. That is a very nice problem, and we should try to solve, and we should also try to understand the topic. That is very important. The figure shows steady state operating data for a well insulated device with air entering at one location A and exiting at another location with a mass flow rate of 10 kg per second. So mass flow rate is 10 kg per second. Now, neglecting the potential energy changes, determine the direction of the flow and the power. So we have to see that which direction our flow will be there. In the figure, it is given that at A section, pressure is 1 bar, temperature is 600 Kelvin, and V is here 100 meter per second. Here at the B section, which is a 5 bar pressure, temperature is 900 Kelvin, and the velocity is 5 meter per second. So we have to see that which direction. Either it will go A to B or B to A. Which direction our flow is going, that we have to see, and in this discussion we will be trying to solve this problem in this way. Now we can see that here given rate of mass flow is equal to 10 kg per second, delta PE is equal to 0. The system is insulated, so delta Q dot also is equal to 0. Using the first law of thermodynamics for the control volume system, we know that dE by dt is equal to Q dot minus W dot plus MI, this is the inlet, HI plus VI square by 2 plus GZI. So minus M dot exit, E for exit, HE square plus VE square plus ZE square. So here we can see this MI, we can write it as a W dot is equal to. So now here these things are cancelled. So here this is work. So if you take this side, it is a plus. So work done, rate of work done, that is W dot is equal to MI. Initial is equal to 10. We are assuming that it is from A to B. So A is a inlet and B is a exit. So here W dot is equal to 10 into here HI we can take at a 1004.5 into 600 plus it is V is equal to 1000 square by 2. So here this H is equal to Cp and the T. So and Cp is equal to gamma R by gamma minus 1. So if we calculate, we will get 1004.5, and so this is put from here. This is the HI. So here we can see that W dot we will get plus minus 1986 kilowatt. So we have to take plus or the minus. Plus if A is inlet and minus if B is inlet. So it is going to be the adiabatic process, that is the Q dot is equal to 0. So given at A is equal to P is equal to 1 bar, T is equal to 600 Kelvin. So now we have to see that TDS is equal to DUT plus PDV. So DU plus PDV, we can write DH minus VDP. So now DS is equal to DH by T minus VDP by T, because we can say that V by T is equal to R by P here. So here DH we can write Cp dt by T minus R by P dP. So by the integration we will get Cp ln T2 minus T1 minus R ln P2 minus P1. So here if no heat transfer, the enthalpy will give the direction. So in the steady state, dE by dt is equal to 0, and the mass conservation dm by dt is equal to m dot I minus m dot E, and dm by dt is equal to 0. So m dot I is equal to m dot E is equal to 10. Means everywhere the m is equal to 10 here. So we have put here the value of 10. So here we got delta S means change in entropy. What is the delta S? Change in entropy is given by this equation, that is Cp ln T2 by T1 minus R ln P2 by P1. So now we can see here that delta S is equal to Cp delta T by T minus R by P dP. So this delta S is equal to Cp ln T2 by T1. So this here we can see that the delta S is equal to Cp delta T by T minus R by P dP. So here delta S is equal to, we will put this value here, Cp ln T2 by T1 minus R ln P2 by P1. So here we got this 1004.5 into ln 900 by 600 minus here Cp is equal to 287, R is equal to 0.287 into 5 by ln 5 by 1. So you will get here 407 minus 2.28 is equal to 461.9. So delta S is equal to minus, here you are getting the negative. Delta S is equal to negative, which is not possible, which is not correct. As per this change in entropy should be always positive. So the direction chosen was not correct. So A to B is not correct. Flow must be from B to A. So if it is B to A, now work done W dot is equal to plus minus 1986 kilowatt flow is from B to A, so negative sign will be taken. So for this work, we have to take the negative sign. This is the correct, because here it is negative, so we have to take here the negative. Work is negative. So in this way, we have find out the direction of the flow. Also, we have find out the work done of the system in this way. Now, we will see the next topic. I will discuss in my next lecture. Numerical 1, entropy change in a lake. Numerical 2, changes in entropy of systems and the universe. Numerical 3, direction of heat transfer. So, and this we will see the further that Carnot cycle efficiency calculation, Carnot cycle source temperature, reversible cycle heat transfer calculation, refrigerators COP. These are the references which I have taken from the P.K. Nog, Engineering Thermodynamics, Yunus Senegal, Michael Abols, Thermodynamics and Engineering Approach. Also, this is the NPTEL lecture from our SOYAM portal. Any questions, you are welcome to ask. My email is ydwivedi@gmail.com. This is my email. You are welcome to ask any questions, any queries. Also, I request you people to like and subscribe. This will give me the motivation to further. If anywhere you feel that there is some problem or it is not clear, you can ask me. I will try to amend this video as and when it is required. It is very much essential to give the feedback so that I can improve myself if I have any problems or I am not able to express my view correctly. Thank you very much for the joining, and do wait for my next lecture coming soon. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.